Getting started with dates and times in Pandas. Welcome! In this lesson, we will explore how to work with dates and times using Python and Pandas. By the end, you will know how to load time data, analyze trends, and apply these skills to real-world datasets. Running the cell now. Let us jump in and see how dates and times work. Let us start by turning off warnings so our notebook looks clean. We import the warnings module. We will tell Python to ignore all warning messages. Running the cell now. Next, let us import the main libraries for data handling and visualization. We load Pandas, which is great for working with datasets, especially tables of data. This comment explains that Pandas is powerful for handling dates. We import Matplotlib's pyplot tool so we can make quick charts. A comment to remind us that we will be making time-based plots. Running the cell now. If you do not have these packages yet, you may need to install them with pip. What is a time series? A time series is a list of data points ordered by time. Many real-world problems use time series, like weather reports, sales history, or website visits. Running the cell now. Let us use a real sales dataset to see date and time handling in action. We label this section as our data setup step. We get the address of the shampoo sales dataset online. We load it into a Pandas data frame with read_CSV. Here, we will preview the raw data. This shows us the first 5 rows so we can see how the data is structured. Running the cell now. Try loading the data with a different CSV link if you want to practice. What kinds of things do you notice about the loaded table? Let us check how many rows and columns we have in the data. This comment reminds us that we are checking size. We use .shape to see the dimensions. It returns rows and columns. Running the cell now. If you see 36, 2, we have 36 months of sales data and 2 columns in total. Now we will convert the month column into real dates that Pandas can understand. This comment explains we want the month column to be proper dates. We create a date column, starting in January 1901, once for each row. We use Pandas to convert the month to a datetime format. Here we check the data types of all columns to confirm month is now a datetime 64. This shows us the type so we know if our operation worked. Running the cell now. When Pandas knows a column is a date, we can do much more with it later. Try running dtype checks with other columns if you want to explore. Let us take another look at the table and check month formatting. A reminder that we will review the changed data frame. We show the first 5 rows. Now month should look like a date, not a string. Running the cell now. If month has a date format, we are ready to work with it. Why are dates important in data? Dates let us find trends, make reports, or compare sales between months and years. Time-based insights are behind most business decisions, weather forecasts, and more. Running the cell now. We will use month as the index. This helps us sort, filter, and analyze by date easily. This comment explains why we are changing the index. We set month as the row labels. This makes time-based tools in Pandas easier to use. Preview the result to see that month move to the left as the index. Running the cell now. Try making other columns the index and see how it changes the table. Does your table now list months as row labels? Let us visualize our sales as a time series to spot patterns. We comment that our next step is to make a chart. This line creates a line plot of sales over months. The chart helps us see any up or down trend. We add a label to the x-axis to show it is the month. The y-axis label explains these are sales values. plt.show makes sure our plot appears. Running the cell now. Can you spot a trend, such as more sales in certain months? Try changing the title to make it your own. Common date and time tasks in Pandas. We can select data by time, see trends, group by year or month, and filter by certain periods. Running the cell now. Let us pull sales that happened after January 1902, using date filtering. Comment says what we want to do, select all rows after a certain month. We use .loc with a string date to pull only sales from February 1902 onwards. We preview the top rows to make sure it worked. Running the cell now. Try changing the date to see how filtering works. Now we will summarize sales by year. This uses resampling. We use a comment to tell us we are looking for yearly averages. We resample our data by year, Y, and calculate the mean for each year. The result gives us average monthly sales for each year. Running the cell now. You can use resampling for many time steps, like quarter or week, too. Let us find out when sales peaked. The comment explains we want to pick the top sales month. This finds which month had the biggest number by index. Here we get the maximum value itself. We print the year and month in a readable way, along with the sales amount. Running the cell now. What was your highest sales month? Often, we want to focus only on the year part for groupings or summaries. We comment our goal is to keep only the year. This creates a year column taken from the index, which has dates. Preview the table to see our new year column. Running the cell now. Try adding a column for month only with shampoo.index.month. Sometimes our time data may have missing or doubled rows, which can break analysis. We comment that we are fixing issues in the date column. This code keeps only rows with a unique date, removing duplicates. Here we delete any rows that have a missing value. This keeps only clean data. Running the cell now. Always check your real datasets for missing or weird values. Let us try converting a date the user types into a real Python date. We will use the datetime module to help us. We import datetime from its module for parsing. This asks you to type in a date in year-month format. This is the start of our check. We will now watch for errors. Here, we try to create a datetime object from the string you typed. If this works, we show the parsed date. If there is an error, this except block will catch it. If the text is not a proper date, this tells the user. Running the cell now. Try invalid input too, like 1901 to 32 or just March. As a small challenge, let us list all months where sales were above 500. The comment sets up the task, select months with high sales. We use a filter to find sales greater than 500, then list each date as YYYYMM. We print the list. These are the months you did best. Running the cell now. Try changing the 500 to another number to see other results. It is time for a bigger project. Let us compare total shampoo sold for each year. We are grouping by year to add up sales for each one. This groups all sales entries that have the same year, then sums them. The result shows each year beside its total sales. Running the cell now. Try making new totals for months or by quarters. For even more practice, try plotting these totals as bars. Whenever you are handling dates, make sure they are real datetime types. Comment suggests a habit: always check date format. We say what is being shown. This prints the data types for every column. Running the cell now. Just remember, treat date columns as datetime for easy time calculations. Here are ways to spot problems you might run into. We add a tip, checking for common issues like repeated or missing dates. If we see any duplicate row labels in month, we print a warning. This line displays a warning that duplicates exist. This checks for empty cells anywhere in the table. If data is missing, we suggest how to fix it. Running the cell now. Common mistakes are small typos or missing rows. Just take it slow and check. If you want to explore changes safely, always make a copy first. We comment a tip: use .copy before editing data. This line makes a separate copy called shampoo_copy. We print a quick friendly message so you know it worked. Running the cell now. Try removing rows, sorting, or renaming in your new copy without worry. Challenge exercises. Select data before 1902. Find out which month had the lowest sales. Create a new column for the month number 1 to 12. Running the cell now. Try solving one or all of these on your own for great practice. Summary: what did we learn? Working with dates and times helps us see trends and answer business questions. Pandas makes it easy to clean, filter, and plot time data. Always use date-time types for real-time series power. Running the cell now. What other time series would you like to try? Maybe weather or online visits. Next steps: share, like, and practice. If this helped you, please like the video and subscribe for more Python projects. Practice on your own datasets and see what you can discover. Running the cell now. Keep learning and see what you can create. Thanks for learning with us. See you next time.